What's up, guys? Hey, Bennett. How are you doing? Are you done with finals? Are you back? My guess is that you guys probably ended a little bit earlier, but I don't know. We've had a lot of alumni come back in the last couple of days. No, you're not done yet. When are you done? That's not bad. I'm fine. I have a couple of things to finish in my class, and then I'm done for the until next semester. But it's been good. All right. It's 5:25, so I want to at least start. Uh, this is in on campus as usual. I'm gonna skip all of the notes section because you can go back to previous videos for that. Um, Simple kind of final exam. Question one: find vertex and zeros. Um, Number two: graph of a higher order polynomial. Number three: graph a rational function. Four: from zeros create a function. Find zeros of a quadratic or higher. Seven: verify whether or not something is a right triangle. That's the distance formula. And number eight is just simply graph an equation of a line, or get an equation of a line. So not super hard. I just want to make sure that we know this before. But there's a couple questions that can go a lot of different ways. This will definitely look different. Okay, it's probably not going to be two terms. It could be cubic. It could be x to the fourth. Bottom line is, though, you're going to have to be able to factor this in some way, shape, or form. So being able to do that is really hard. It's really important. Not really hard. It's just sometimes it takes time. Okay, so that's the first one that can look different. It's not going to be two terms. It could be x squared. It could be x to the fourth. It could be x cubed. There's a lot of different ways that number two can look. Okay. Number three can look a whole lot of different ways. All right. Like I said in class, these degrees can be different, and those have different relations with one another. Okay. You could also get two asymptote or two zeros down below, so you could have two vertical asymptotes. This one can look different, right? I could give you 2 real and 1 imaginary. There's a whole lot of different things that those can be. 5 and 6. 5 and 6, I'm hoping that we can use our calculator on. That's the goal. Just put it in a graph and find the zeros. But I'm going to make it so you're able to factor it or use something that's not just a calculator in order to find it. So it's doable without a calculator. It just takes a little bit more time. Number 7, that's just about what it is. And number 8, that's something we've been working on for years now. So we should be able to do that. Okay, so just a couple of things that can look different. So 4, 3, and 2, those might all look a little bit different than the ones that I have on here. So this is just an example. And you've had other examples. I'll kind of talk about that when I get there. So I just want to start. As you have questions, let me know. I'll try and answer them the best I can. This is what you were working on today during class. So yeah, all right. Convert the following equation into vertex form, and then label the vertex, and then solve the values of x that make the function equal to 0. Okay, so 2 different things. We need standard form, so we need our equation to look like this. And then we need zeros. So that I phrased it weird for some reason. I'm just saying find the zeros. So 2 different parts, and I'll do these in 2 different colors. All right, first one. So let's get the vertex form and label the vertex. All right, so for vertex form, what we're doing is we are, is it too big? No, we're going to focus on these 2 terms right here. All right, and what we need to do is we need to factor the 5 out of both of those. So we factor the leading coefficient out of both of those, and we're left with n squared plus 4n. And then there's the minus 60 out, still out there. And we're going to ignore that equals 0 for a minute. All right, then we need to actually complete the square. So I'm going to draw this square. Okay. And we need to put everything inside this parentheses inside this box. So n squared is going to go in the top left-hand box. And if the area of that square is n squared, then the length is n and the width is n. Then we're going to split up 4n into 2 equal parts. So we're going to split it up into 2n and 2n. So if the area of these are 2n and one of each of the sides are n, that means this length has to equal 2 and this width has to equal 2. And this will allow us to complete the square, right? So then the rest of this is 2 times 2, which is 4. So the area of this thing is 4. And now we have this completed square, all right? So what we have is we have 5 times n squared plus 4n. We added this plus 4 in here. We had this minus 60 out front, or out back. But because we added 5 times 4, so we added 4 inside. And because we added that inside, we really added 5 times that to the overall equation. So that's 20. So at some point, we need to take away a 20 from all of this. Now, in order to get this to look like standard form, we need to factor a little bit to make it look like that x minus h squared. So we have the 5 on the outside. This set of parentheses factored, that's just the length and the width of this box. That's part of the reason we do it. So that's n plus 2 times n plus 2, so we have n plus 2 squared. And then minus 80. So this is our equation in vertex form. Standard form, same thing. That means our vertex is negative 2, negative 80. So it's always the opposite of what's inside and then exactly what's on the outside. Big final tomorrow, Jack. big final. Okay, so we have the vertex, we have the vertex form, and now we just need the zeros. Yes, you did graduate. Congratulations. All right. So then we need to find the zeros. In order to do this, there's a whole bunch of different ways we could do it. I'm going to do it the way that I find probably easiest given the work that we've done. So we've done this work. We found this thing in vertex form. If we just set that equal to 0 and start to solve, we'll get the zeros. All right, so if we add 80 to both sides, divide by 5, and then we take the square root of both sides. So we have n plus 2 is equal to plus or minus 4. So then n is equal to negative 2, right? We subtract the 2 over, and then plus or minus 4. Okay, if we get here, we're good. Those are the two zeros. If you want to simplify, negative 2 plus 4 is 2. Negative 2 minus 4 is negative 6. So these are our zeros. That's the way to do it kind of in one like fell swoop, I guess, one idea. So that's like one motion we did it in. There's a bunch of different ways to do this, so I want to show you one of them. All right. Another way we could go about this. So again, if this whole thing makes sense, don't worry about this. I just want to give you options. What we could do is straight away just factor this thing. And if we continue to factor this, we're going to get n plus 6, n minus 2. So we get n plus 6 equals 0, or n minus 2 is equal to 0. So n is equal to negative 6, or n is equal to positive 2. Again, I'm reminding you, this is just a different way to do this problem. If the stuff in blue on the left makes sense, don't worry about this. So we have two zeros now. Our vertex is going to be directly in between those two zeros. So negative 6 plus 2, that's negative 4, divided by 2, that's negative 2. So our first part of our vertex is going to be negative 2. And then we need to plug that back in. So if we do that, this is going to equal 5 times 4, which is 20, minus 20, sorry, minus 40, minus 60, which is negative 80. So then our vertex is negative 2, negative 80. So that's our vertex. And then from that, we have standard form, which would be x plus 2 squared minus 80. And then we just stick our leading coefficient out front, and then we're done. Okay, so two different approaches to the same problem. Whatever you're comfortable with is fine. Number 2, graph the following by using the leading coefficient test, finding the zeros, and using the intermediate value theorem. Show all work. All right, so I'm going to get rid of this. First thing, leading coefficient test. So our degree of this thing is 4. That's the highest exponent. People today were saying 2 because that's the one in front. That's not how it works. It's just the highest degree of x. So this is 4. So this is even. Our leading coefficient is the thing attached to that x to the fourth. That's 3. This is positive. And then we need to find the zeros. So again, being able to find zeros, like we have all the tools to do that. We just have to do it. I'm going to look at this problem overall, and I'm going to take out the greatest common factor because there's only 2 terms. The greatest common factor of this thing, I'm going to take out negative 3x squared. Actually, I'm just going to take out x squared. I'm just going to take out 3x squared. And what's left is negative 16 and then plus x squared. So if we factor it and set that equal to 0, then either 3x squared is equal to 0 or negative 16 plus x squared is equal to 0. So x is equal to 0 or x squared is equal to 16, which means x is equal to plus or minus 4. So those are the zeros. We've got 3 of them, really 4 of them, because we could rewrite this as 3x, x equals 0. So x equals 0 or x equals 0. It's the same. It doesn't matter, but that's usually when you see like multiplicity 2, that's what that means. So then we're going to graph it. So we've got x equals 0. X equals 4, and x equals negative 4. We know from our end behavior, from this stuff, even positive, that we're going to go up from the top and up to the right. Our job is to test between the zeros now, because we need to see what happens in between. So if we test between the zeros, we're going to test something between 0 and negative 4, so let's test 1. That equals negative 48 plus 3. That's negative 45, so it's negative. So we're going to come down below the x-axis, and we're going to come back up to that 0. Then we test something to the right. Sorry, that should be... I tested 1, so that should be on the right. And then if we test negative 1 on the left, that's still negative 48 plus 3, which is negative 45. So we're going to go below the x-axis, and then this is our graph. Again, there could be more than 2 terms. It doesn't have to be x to the 4th. This works out like this because that's just how it's structured. Bottom line is, though, we need to be able to find zeros of quadratics especially, but we also need to be able to factor bigger things out. So that's number 2. Number 3, graph each function by finding the vertical and horizontal or slant asymptote, as well as any holes in the graph. Show work. I'm not worried about holes. That is just remnant of another class. But we still have kind of a direction to go. So first we're going to find a vertical asymptote. Finding the vertical asymptote, we are just finding when we get unbounded behavior, which is when the denominator is equal to 0. So we're going to take our denominator, set it equal to 0, and then solve. So if we add 3 to both sides and then divide by 3, we get x is equal to 1. Then we're going to check for our horizontal. To check for horizontal asymptotes, we're going to compare degrees of the numerator and degrees of the denominator. N is going to be the degree of the numerator. That's equal to 2. M is the degree of the denominator. There's x to the first there, so our degree is 1. This means that n is greater than m, so there are no horizontal. But because there's no horizontal, we have to check for a slant. In order to get a slant asymptote, we take our denominator and divide it into our numerator. And keep in mind, this is one of like 3 possibilities. So I'm going to write that before I do this. So if n is less than m, so if the degree of our numerator is less than the degree of our denominator, this says that y equals 0 is a horizontal asymptote. If they are equal, you take the ratio of the leading coefficients. And then those are the 3 possibilities. So you either get y equals 0, y equals the leading coefficient of the numerator over the leading coefficient of the denominator, or no horizontal asymptote at all, in which case you have a slant. All right, so just so that's kind of clear. So then we do this long division. So how many times does 3x go into x squared? So what times 3x gives us x squared? That's 1/3 x. 1/3 x times 3x, that gives us x squared. 1/3 x times -3 gives us negative x. We subtract those things, we're left with 0. We bring down the -3. That's a remainder. So really we would get plus -3 over 3x minus 3. I'm not worried about this remainder. For slant asymptotes, all we're worried about is this equation. Okay, so y equals 1/3 x plus 0. So 0 is our y-intercept. And then we're going to go up 1, right 3. So now we have the kind of the structure of our graph, and we need to test to the right of our vertical asymptote and to the left. So let's test to the left first. So we plug in 0. When we plug in 0, we get 0 minus 0 minus 2. It's just minus 2 over 0 minus 3. So we get 2/3. So we get this point like right above that slant asymptote. So all of our graph is going to be above that slant asymptote. I'll do this in a different color. Then we test to the right, so let's test 2. So we get 2 squared minus 2 minus 2 over 3 times 2 minus 3. Our denominator is 0. So our entire thing is 0. So 0 is like right here. So that means our entire graph is going to be below that slant and then to the right of that vertical. Okay. So everything in blue, that's like our actual graph. Red is kind of how we get there. So that's number 3. And then things start to get a little bit quicker. Okay. Number 4 says find a polynomial function with real coefficients that has the given zeros. A bunch of correct answers that you could do. So for this example, or for this problem, we have a couple of zeros. So we have x equals -4i, x equals -2, and x equals 2i. So if that's the case, For imaginaries, we have, so sorry, I'll kind of scoot back. For these zeros, the corresponding factor is x plus 4i, x plus 2, and x minus 2i. For the imaginaries, we also have the conjugate of that, so x minus 4i and x plus 2i. So we get all those factors, and our job is to multiply all those things together. So to do that, I'm going to FOIL these top two together first. So we get x times x, that's x squared. X times negative 4i, that's negative 4xi. 4i times x, that's plus 4xi. And then 4i times negative 4i is negative 16i squared. X plus 2 is just going to stay there. X minus 2i times x minus 2i, if we do kind of like the same thing we did above, we get x squared minus 2xi plus 2xi. I did it kind of in reverse order there, but it's the same thing. And then minus 4i squared. If we simplify, this becomes x squared plus 16. This is still x plus 2. And this is x squared plus 4. Okay, the reason it becomes plus 16 and plus 4, the minus 4xi and plus 4xi, those cancel. And then negative 16i squared is really negative 16 times negative 1, which becomes positive 16. Same thing down here. We get negative 4 times negative 1, which becomes positive 4. So now our job is to just multiply these three factors together. There we go. So we have x squared plus 16, x squared plus 2, just x plus 2, and then x squared plus 4. What is positive I squared? So if we remember, I is just equal to the square root of negative 1. So I squared is square root of negative 1 squared, which is just negative 1. Negative I squared would be positive 1. Positive I squared is negative 1. So then we just have to FOIL a bit more. So if we do this piece by piece, so multiply two together at a time. X squared times x, that's x cubed. X times x squared times 2 is plus 2x squared plus 16x plus 32. And then we have one more of those things to go. X cubed times x squared, that's x to the 5th. X cubed times 4 is 4x cubed. Two x squared times x squared is 2x to the 4th. 2x squared times 4, that's plus 8x squared. 16x times x squared, that's 16x cubed. 16 times 4, that's 64. (32 times x squared is 32x squared. And 32 times 4 is 128. So we could stop there. You can add a couple of things together if you want, but this is being able to FOIL like that is important. So we get x to the 5th, 4x cubed plus 16x cubed, that's 20x cubed. We have a plus 2x to the 4th. we have a bunch of x squared. So 48, it looks like. And then 128 plus 64. 192. And that'd be our answer. Number 5 and 6, I'm not looking for any work. I'm hoping that you do this on a calculator, but you can also factor it. All right, or use the quadratic formula, whatever you want. So I'll do one of each. I'll do one with the quadratic formula. I'll do one with factoring. I can't really show you how to do it on a calculator on this, but if you know how to do it, it takes like 10 seconds. Okay, so let's factor this one. So if we factor this, we need factors of -1 such that these two empty ones add up to +1. So let's do 1 here and -1 here. So -x and 2x. Those add up to positive x. So 2x minus 1 times x plus 1. Those are factors. So x equals 1/2 and -1. So A is our answer. Again, you can use the quadratic formula if you want. I'll do that on this one. So x is -b plus or minus the square root of b squared minus 4 times a times c all over 2a. -7 plus 1 is -6 over 6, so we get -1. And already this is out. -7 minus 1 is -8 over 6, which is -4/3. So -1 and -4/3, that's our answer. So C is our answer. Number 7, verify whether or not the following points are vertices of a right triangle. Show all work. It is not enough to draw the triangle. Okay, so we can't just draw a triangle and say that's a right triangle and we're done. The purpose of this is to use the distance formula a bit. Okay, so we have to find the distance between each of these 3 points, plug it into the Pythagorean theorem, and verify whether or not it's right. If it is, we have a right triangle. If it's not, we don't. So let's find the distance between these 2 points. And I'll write the distance formula right here. So we get 3 minus 3 squared plus 2 minus 7 squared. So we get rad 25. I'm not going to worry about simplifying because that's going to take care of itself here in a minute. Then I'll do the distance between these 2 points. So we get 6 minus 3 squared plus 2 minus 7 squared. So that's 9 plus 25, which is rad 34. Yeah, 3 squared is 9. 5 squared is 25. 25 plus 9 is 34. Great. And then I will find the distance between these 2 points. Which is going to be 6 minus 3 squared plus 2 minus 2 squared. Which is just square root of 9. Our biggest value is going to be our C value. We can call the other two A and B. And we should have that A squared plus B squared we need to see if that is equal to C squared. So rad 25 squared is just 25. Rad 9 squared is just 9. Rad 34 squared is just 34. This is a true statement because we have 34 is equal to 34. Therefore, this is a right triangle. Again, I'm not necessarily going to give you a right triangle. It might not be a right triangle, and you have to prove either way. And this is how you do that. Take the distance between all of them, see if it fits the Pythagorean theorem. If it does, we have a right triangle. If it doesn't, then we don't. And then the last problem, just find the equation of the line through the given points, show all work. Anytime we're given 2 points and we're trying to find the equation of the line through them, we have to find the slope. And there are 2 different equations you could use here. You could do y minus y1 is equal to m times x minus x1. That's point slope form. Or you could do y-intercept form, or slope-intercept form, which is y equals mx plus b. Regardless, we have to find a slope. Slope is the difference in y's over the difference in x's. So we get negative 6 minus negative 4 over negative 1 minus negative 7. So that's negative 6 plus 4, which is negative 2. Negative 1 plus 7, which is just 6. So our slope is negative 1/3. And for point slope form, this is easy. We just pick one of these points. So we get y plus 4 is equal to negative 1/3 x plus 7. You could also use slope-intercept form. So let me just stop. That's it. That's it. You have to find the slope. You have to find the equation of line. That's good. If you don't do it using point slope form, like I just did in red, you still have to find the slope, but we would plug in our y1 value is equal to negative 1/3 our x value plus some b. So we get negative 4 is equal to positive 7/3 plus b. We'd subtract that over. So we get negative 19/3 is equal to b. And then with that, we get y is equal to negative 1/3 x minus 19 thirds. So either one, whatever you're comfortable with. I think the red is faster and easier, so that's the one I always use, but that's up to you. Okay, so that's the entire test. There's not a lot. It's decently simple stuff. I just did that while explaining everything in like 35 minutes. So we should be able to finish this definitely in 90. Okay. So I'm going to leave this open for like 2 more minutes or 2 minutes. If you have questions, please let me know. I'll kind of slow scroll through. If not, that's okay. If there's no questions, I'll end it there. All right. So I'm going to mute myself. I'll scroll back up to the top, slow scroll down, and then we'll go from there. As I'm scrolling through this, I just want a word of caution on number 2. It's probably not going to look exactly like this. All right, so there could be 3 terms. It doesn't have to be to the power of 4. It does not have to look like this. It can look different. Okay, so just seeing what I did here, what I did is I found the zeros all throughout here. The leading coefficient test is the exact same. Finding zeros is not always going to look the same. We still need to be able to do that. And also here, right? It's not necessarily going to be a slant. There's not necessarily just one vertical asymptote. We need to be able to do really any of these problems, but there's only going to be one. Okay? Don't worry about the holes. That doesn't matter. Okay, it doesn't seem like there's any questions, so in the next minute, set a timer. In a minute, I'm going to end this. If there are questions before that, I will take them and try and answer them. Otherwise, it'll be over. Okay, so it's okay if you're just coming in late or you missed most of it. This will be back up in like a couple minutes. I'm going to start another review here in a little bit for my stats guys, but this still should be up. Okay, So I'm going to mute myself. If there's any questions within the next like 40 seconds, I'll try and answer them. Okay, it doesn't seem like there's any questions, so I'm going to end this. If you have questions in the morning, feel free to come in or email me. Otherwise, good luck, and I will see you later.